Okay, here we go. So, more of what we did yesterday. So, kind of nice. There's a new code right there. Okay. All right. Yes. Yes. Will you see if number 30 is over there? Maybe number 30 is. And yeah, but yeah, Ruth, then you take that. But check in Mr. Day's room and see if one of my calculators is in there also. Thank you, dear. Okay. So we're doing more of what we did yesterday. So we have, these are rational fractional power functions. So again, a power function was a function where there might be a number in front, but we have x to some power n, any power, right? So as long as your a isn't 0 and the n is not 0, it's a power function, but it turns out that that nth power can also be a fraction, all right? And so just as a reminder, when we have rational fractional exponents, this is the nth root of x to the m power. So it is a rational or a radical function as well. And so what you want to think about here is that, well, we already know that the square root of x has a particular shape. What does the square root of x look like?
Oh, like a
swoop. Yeah, it's the square root swoop. And that's what it looks like. And again, that would be the same thing as writing x to the 1/2. So when you see a function that has that rational exponent, you got to think, oh yeah, that's really like a square root kind of graph, okay? And so we want to make sure that we remember that it sort of has this sort of a swoop shape to it. So once again, when n is an even root, so if it's a square root or a 4th root or a 6th root, the domain is restricted. So this is actually a mistake. It's not technically positive. It's more accurate to say non-negative. Non-negative. What does non-negative mean? That is a weird phrase. Non-negative. Not negative. Okay. Not negative. So the question is, where does 0 fall? Is 0 positive? No. Is 0 negative? No.
It's not negative though, but it's not.
It's not. It's neutral. Yeah, 0 is neither positive nor negative. So it's the domain gets restricted. So non-negative really means that x can be greater than or equal to 0. And that's what non-negative means, okay? None of the negative values, but 0 and positives work just fine. So anytime you have an even root, we have a domain that is restricted, and that matches our little square root swoop, right? We talked about our little square root swoop. The domain on this curve starts at 0, and it goes forever to the right. And that is the same thing as this is saying, that x has to be greater than or equal to 0. Okay, so just like yesterday, we can graph these. We want to sort of have a general idea of what these things look like. So we know they're kind of swoopy, but we can use our calculators and plug them in. So we get x to the 1/4. I'm going to do Zoom standard. And I'm expecting a swoopy type shape. And did I get a swoopy type shape? Yeah, I did. Except what's happening here, if I got that 4th root, it's just really stretched sideways, like is really what's happening here. So it is just really a very shallow swoop, shall we say. Domain. So looking at this graph, how far left and how far right does it go? 0 to infinity. Yeah, I could just say x must be greater than or equal to 0. That's the picture as well. All right. And what is the range? How low does it go and how high does it go? 0 to infinity. So I could write 0 to infinity if I wanted to. Or y has to be greater than or equal to 0. So either of those things will work just fine. 0 to infinity with the bracket in parentheses, or x is greater than 0, y is greater than 0. X-intercept, 0, 0. That's the same. Yeah. Origin, the origin, or the intercept. All right. Tell me, is this function increasing or decreasing? Increasing, yeah. So it's increasing over 0 to infinity. Technically, it's a bracket, but we're just going to use open parentheses there.
It's like frozen. It started to do it.
So, whoops.
Wait, why wasn't it be a bracket?
So it technically is a bracket. 0 is the first point, and the point to the right is definitely higher than that. So technically, it is a bracket. So it's not. I'm not going to grade it either way. Neither will Delta Math. It won't care if you use a bracket or parenthesis, and this is because of the calculus test. On the AP calculus test, they don't nitpick these things because that's for a higher level of math. That's essentially what it comes down to.
It's like you don't care right now.
Yeah, we're just not going to bother with that right now. Is sort of what it is.
It's like the grains of salt.
Yeah, exactly. Yeah. So, is it decreasing? No. So there is none. Symmetry. Any symmetry? No. Any discontinuities? None. And end behavior. So as x approaches negative infinity, as x approaches positive infinity. So as x, can x go to negative infinity? No, wait a minute, that doesn't work in this case. Why not? Is there anything over here? No. So how far to the left can x go?
0.
Oh, it can go to 0. Okay. So as x approaches 0, what does our function approach? As we are moving to the left, yeah, okay, so as x is approaching 0, what is our function doing? It's stopping at 0, yeah. F of x is approaching 0. Okay. And then as x approaches positive infinity, so now as x is moving to the right, all the way over here to positive infinity, what is our function doing? Going also upwards to eventually positive infinity, okay? It does go up forever. You just have to have a really good imagination. Okay. All right, questions on that one? No? Okay. All right. It's the same thing as yesterday, yeah? All right, let's look at this one. This one's interesting. This is a fifth root. Yeah, so it would be slimmer. Is it just half of a curve here, like the even one, or is this one going to be full, like side to side? Yeah, it's going to be a full side to side one. Let's see what happens here. So again, when in doubt, we have calculators. Thank the Lord. All right, so 1/2 x to the 1/5 power. Yeah. So there it is. It's a really skinny cube root like. So x to the cubed root of x is that side to side curve. So that's sort of like this one. So it's like an odd sort of power. It is skinnier, so to speak, I guess you could kind of say. So, but there it is, something similar to that. It's really skinny. And so what's the domain? All real numbers. Very good. Negative infinity to positive infinity. What's the range? All real numbers. Again, it is going down as it moves to the left. So it will eventually get to negative infinity. And then it's moving up as we go to the right. So it'll eventually get to positive infinity and cover all of those y values in between. Intercept? 0, 0. I don't like that question. Increasing interval. Is it just 0 to infinity? We are increasing here for sure. But on this side, what are we doing? We're also increasing. Going uphill. So again, we read from left to right. So you put your pencil on the left and say, is my pencil going up or down? Well, so we're just going to say it's increasing from negative infinity to positive infinity. You could probably put all real numbers. That wouldn't be improper. Is there decreasing interval? None. Symmetry. Origin, yeah, it is. Origin symmetry. What that means is if we found a point like right here, it spins around and just becomes exactly opposite. Spins around the origin. All right, any discontinuities?
No.
None. End behavior. As x approaches negative infinity and as x approaches positive infinity. All right, what is our function doing as we approach the left? As x approaches negative infinity, that's over here. What's our graph doing?
Going down.
Yeah, it's going down to negative infinity. And then as x goes to positive infinity, that's on the right side of our graph. What is our function doing? Oh, going up to positive infinity, eventually. Let's have a good imagination. Takes a long time. All right, how you doing?
Very good.
You're good? All fine and dandy? All right, these
It's
next...
really like yesterday.
It is exactly like yesterday, yeah? So, but the graphs get really kind of crazy here, so. This one's real interesting. So, looking at this one, before we graph this one, what are your guesses? So, is it going to be more like the cube root or the square root function? Square root, because the root is a 2. So, it is. It's going to be upside down because of the negative. That's good. Hey. All right. So then there's some weird stuff that's going on.
Would it be upside down and like sideways?
It's so weird. It is. It's totally weird. Negative 3 x to the 5 halves. Here we go. Crazy. That was amazing.
Guys, I'm so smart.
All right.
That comes from 0, right?
Yeah, it does get all the way to 0. Let's see. I'm going to hit trace and see what happens when x is 1. So you can see when x is 1, it is actually at the point 1, negative 3. So it would have been at the point 1, 1, and then we multiplied it by negative 3. And so it turned into 1, negative 3. And that's why it is sort of crazy weird. All right. So there's that graph. It's very interesting. What's our domain?
0.
0 to infinity, or x is greater than or equal to 0. Ooh, for all the money I don't have in the world, what's the range? Negative infinity to 0. Negative infinity to 0. And what did you say, Thomas? Y is less than or equal to 0. Yes. Awesome. Thank you. Okay. Beautiful. All right. Yes. So same thing there. Y is less than or equal to 0. So either of those is great. X-intercept at 0, 0. Same as the y-intercept. Increasing. Is this function increasing or decreasing? It's definitely going downhill. So starting at the left side here, we're going downhill. So decreasing. There is no increasing interval. Where is it decreasing? 0 to yes, wait a minute. 0 to infinity. 0, because we're talking about the x-axis. So from 0 all the way to infinity, as x goes from 0 to infinity. Yeah, it's weird. Yeah, hard to think about. But the interval we're talking about is on the x-axis. So as x goes from 0 to infinity, we are decreasing. All right, that's what that says. Symmetry? None. Discontinuities? None. End behavior. Ooh, as approaches 0. Very good. We can't go to negative infinity because that's not allowed. That's out of our domain. So as we approach 0, what is our function approaching? 0. And then as x approaches positive infinity. So as we move all the way right on the graph, where is our function headed? To negative infinity. Good. Okay. So these are examples in radical form. What we can do, what I think is the easiest thing, is just to convert it to power function form. So the negative's out in front. This is going to be x to what power? 2/3. Very good. X to the 2/3. So what shape are you thinking this is before we graph it? So is it like the square root or is it the cube root? The one that goes side to side. Cube root. Okay. And then the negative is going to do what? Flip it upside down, yeah? Okay. So let's look at that. So we have the negative and we have x to the, well, this is a real interesting one. 2/3. It's weird, huh? So what I want to talk about is what's happening here, because I think it's really, really quite interesting. I want to get rid of the negative, first of all. And if it was just, oh my goodness, there we go. X to the 1/3, we know that this is our side-to-side sort of curve. All right. For the range, so the range, well, I'll talk about it in a second.
I don't think so because it's not separated.
Right. No. So here is that cube. And what's happening is we're squaring this. When you square something, if you take something that's negative and you square it, like a -3 times -3, what happens to it? It turns positive. So what's happening is when we're squaring this cube root function, anything negative is going to flip positive, all right? And so what happens is when we square it, it's going to take that bottom half and it's going to square it so it's positive. And, of course, we're squaring, it's going to get larger, right? So that's how that happens. The 2/3 takes something negative and flips it positive. And, of course, everything gets a little taller because it's larger because we squared it. And now, I call this the bird graph. You know, like when you were drawing pictures of birds when you were little, right? Oh. Right? Yeah. So that's the bird graph. Now, and then, of course, it has the negative in front. And so that's what's going to flip it upside down. So this is, I don't know what we would call this, but anyway, so here is your curve. It does go through 1, -1. So there we go. That's our crazy curve. It's kind of interesting. What's the domain? All real numbers. It goes forever to the left and forever to the right. And what's the range? So this was the question asked. How low does it go? -infinity. And how high does it go? 0. So that's a bracket at 0. Or we could say y value is less than or equal to 0. Again, our x-intercept is at 0, 0. What's our intervals for increasing and decreasing? Well, first of all, so this curve is increasing and this curve is decreasing, okay? So the increasing interval, Brody, what were you saying? Yeah, -infinity to 0. And again, when we talk about an interval, we're talking about an interval on the x-axis. So all the way from -infinity all the way to 0, our function is increasing. So from -infinity to 0. And again, whether or not you use a bracket or parenthesis is not important. And where are we decreasing? On the x-axis, according to the x's? Yeah, from 0 all the way to infinity, our graph is going downhill. So from 0 to infinity. Symmetry? Y-axis. Yeah, this is a flip from side to side here, reflecting over the Y-axis. So symmetry with respect to the Y-axis. Any discontinuities? None. And the end behavior. As x approaches negative infinity, what is our function doing? Yep, going to negative infinity. And as x approaches positive infinity, so as we move to the right, where's our graph going? To negative infinity. All right, last one here. This one's real interesting. Again, I sort of like thinking these things through. So it's a square root. So is it going to be a full curve or only half a curve?
This is what how we're going to calculate.
It looks weird on the calculator, isn't it? Well, and then what is this 27 doing? Oh, it's so weird, isn't it? Let's just look here. 27 minus x to the third power. Oops, did it stop there? Yeah, it does just stop there because, again, it's a square root function. Oh, does it just stop there?
Yeah.
Well, on the table, it doesn't. So this is where it's important to really think about what's going on here. So if x equals 3, let's see, and we plug in a 3, 27 minus 3 cubed, that'd be 0. So that's your y value. So what's happening here is your calculator's not as smart as you are. All right? And this is where this is a great question because it forces you to actually think about, well, does it just float like that or does it actually hit? And it does actually hit at 3, 0, which of course is pretty easy to check just plugging it in. All right, so if I take my value for x of 3 and plug it in, I get the square root of 0. So it should have an order pair of 0. And like Avery said, she checked the table and it does go, right? Yeah. So you have to be smarter than the average check. Oh, Trace. So, and then, so at 0, it's crossing at 5 plus. So 1, 2, 3, 4, just over 5. So it's kind of an interesting curve. It does go on up from there. But this is one of the great examples of you've got to be smarter than your calculator. But I'm going to stop right there in terms of, should we stop right there? No, wait, what's the domain? Let's do domain and range. So if we're talking domain, that's how far left and how far right does it go? Negative infinity to 3, yes, including the 3, so bracket on the 3. Yes, the range. The lowest y value is 0, so it goes from 0 to infinity. So bracket 0 all the way up to infinity. Good. Is this an increasing or decreasing function? Decreasing. Got it. Start from the left, going downhill, decreasing. So the decreasing interval on the x-axis is from negative infinity all the way to 3. All right. No symmetry. Oh, and again, in behavior. This is another tricky one here. We'll do in behavior as well. A hole, a jump, or an infinite discontinuity. All right, in behavior. As x approaches, negative infinity. Can we go to negative infinity? Yes, we can. Negative infinity is way out here to the left. Where does our function go? Up, yeah. F of x goes to positive infinity. And then, as x goes to 3, very good. X can only go as far as 3. We had to stop here at 3. Where is our function going to? Where? 0. Yeah. So our function is boom. hitting 0. Yeah. All right, very good, ladies and gentlemen. That was awesome. Thank you for your attention. That it is another